Okay, I want you to just completely forget everything you thought you knew about empty space. Seriously, throw it out the window. Today, we're diving into a really fascinating explainer covering Dr. Ahmad Rahan's insanely ambitious hypothesis. It's essentially a proposed theory of everything that reimagines the very fabric of our universe. Instead of just a vast emptiness, imagine a cosmos built entirely out of nested bubbles and spiraling energy. It's a visually stunning concept, and we're going to break the whole thing down together, step by step. Here's our quick roadmap for this cosmic zoom. We'll start with the ultimate physics puzzle, move into this universe of bubbles, redefine the true speed of light, scale all the way from atoms to galaxies, and finally, look at how we can actually test this framework. All right, kicking things off with part one, the ultimate physics puzzle. So right off the bat, the big crucial problem we're trying to solve here is this massive divide in modern physics. See, on one hand, we've got general relativity, right? And that perfectly explains gravity and these incredibly massive structures of the cosmos. But on the other hand, we have quantum mechanics, which absolutely nails the incredibly small stuff, like particles and atoms. The catch? They completely refuse to work together. It's like they speak two totally different languages. So the million-dollar question is, can we unite them without having to invent complex, totally invisible dimensions just to make the math work out? Now, to solve this headache, standard candidates like string theory often rely on unseen extra dimensions. I mean, we're talking highly complex math that's incredibly difficult, if not impossible, to actually test right now. But Dr. Rihan's framework takes a totally different route. It sticks to a strictly three-dimensional reality, the one we actually live in. It uses this nested bubble geometry to naturally bridge the gap between the big and the small, and it does it without needing to magically insert arbitrary parameters or hidden dimensions just to balance out the equations. Moving right along to part two, a universe of bubbles. Okay, to really grasp this paradigm-shifting idea, you have to fundamentally change how you picture space itself. Spacetime is not an empty, featureless void. No, it's an actual fabric. Think of the universe kind of like those cosmic Russian nesting dolls. Every single physical system, and I mean from a microscopic atom to a blazing star all the way up to a supermassive black hole, is enclosed by a bubble. And the exact size of that bubble, it's directly determined by its mass and energy. Plus, woven all the way through these bubbles are these filamentary electromagnetic structures. Basically, think of them as a massive cosmic highway system. So how do things actually move around inside these bubbles? Well, you just have to follow three basic geometric rules. First, those filaments we just talked about, they provide the pathways. Second, everything in the universe is basically lazy. It seeks the absolute path of least resistance through the space-time fabric. And in this specific framework, that perfect path of least resistance is always a spiral, or a helix to be exact. And third, all motion tends toward perfect equilibration. Basically, it's a natural balancing act of net momentum and velocity. All right, on to part three, the true speed of light. We've all been taught in school that light travels in a perfectly straight line through a vacuum, right? Well, hold on a second. Under Rihan's framework, which elegantly uses Euler's formula, by the way, a photon is actually pure energy moving in a helical corkscrew trajectory. So instead of just flying dead straight, it's continuously spiraling around one of those electromagnetic filaments. And it turns out this spiral motion is literally the most efficient way for the photon to push through and overcome the natural resistance of the spacetime fabric. And honestly, here is where it gets absolutely mind-bending. The net forward linear speed of that photon, its A to B displacement, is exactly c, the speed of light as we've always measured it. But because the photon is actually taking this longer corkscrew path around the filament, its true path speed is way faster. Depending on stuff like the tilt angle of the filament, the frequency, and the wavelength, the actual speed along that spiral ranges from the square root of 2 times c all the way up to the square root of 3 times c. Crazy, right? Now we know energy and mass are essentially two faces of the exact same coin. Good old E equals mc squared. So it makes sense that they follow reversed geometries here. Pure energy, like our spiraling photon, wraps around a filament axis. But massive bodies? They actually act as the axis themselves. Picture a star. The star is the axis, and the planets, the other masses, spiral around it in their orbital motion. It's the exact same fundamental geometry, just flipped inside out, depending on whether energy or mass is running the show. Moving to part four, atoms to galaxies. Okay, let's really zoom out and consider the sheer scale of this nested bubble hierarchy. At the absolute largest extremes, things like the cosmic web and massive superclusters are basically just the outer envelopes of enormous universe-sized bubbles. If we step down a bit, stellar systems occupy these intermediate bubbles. And if we zoom all the way into the microscopic, atoms themselves are structured as quantized shells, which are essentially microscopic bubbles. So general relativity and massive cosmic structures are simply the macro version of the exact same nested geometry that governs tiny little atoms. And that perfect scaling brings us to the Rihan atomic model, or RAM for short. It's kind of a modern upgrade to the classic Bohr model, but it's grounded entirely in this new nested bubble geometry. It uses these equilibrated surfaces to describe where charges are. But here's the most amazing takeaway. Discrete energy levels and all those weird quantum rules, they aren't forced into the math here. They actually emerge completely naturally, just from the system trying to geometrically balance itself out. You don't have to awkwardly insert extra parameters by hand. Of course, any new model worth its salt has to account for the unbelievable predictive success of our current quantum theories. You can't just throw out the old math that works. And that's where HFQED steps in. This framework preserves the highly accurate calculation machinery of quantum electrodynamics that we already have. But instead of relying on super abstract probabilistic operators where things might or might not be there, it grounds all that math in a concrete, physical, deterministic reality. Photons are helical excitations of filaments, and charged particles are localized, perfectly balanced configurations of the spacetime fabric itself. Finally, Part 5, Testing the Framework. Look, a beautiful idea in science is great, but it isn't enough. We have to be able to actually test it. And one of the boldest claims of this whole hypothesis is the natural emergence of fundamental constants. Usually, numbers like the speed of light, Planck's constant, or the gravitational constant are just arbitrary numbers. We measure them, we shrug, and we plug them into our equations. But in Rihan's framework, they are completely fixed by the geometry itself. They are the unavoidable mathematical outputs of requiring this helical equilibrium. Basically, if the geometry is right, these constants literally have to be exactly what they are.
And what's really exciting is that this model offers a concrete, falsifiable checklist for the future of physics. It's not just a thought experiment. We can actively look for subtle polarization or phase signatures in starlight that has traveled along these cosmic filaments. We can test for precise mathematical relationships between atomic constants using ultra-high precision spectroscopy. We can even look for geometric correlations matching atomic spectra with the vast, large-scale structures of the entire cosmos. We could even build twisted liquid crystal analogs right here in a lab to try and reproduce that predicted spiral speed range. It's an entirely testable roadmap.
As we wrap up this explainer, I really want to leave you with a profound thought straight from the foundation of Dr. Rihan's hypothesis. It freely acknowledges that this is a proposed framework that desperately requires rigorous testing, but it forces us to ask a pretty massive question. Even if future experiments alter or disprove this specific model, does looking at the universe through this beautiful, nested, spiraling perspective completely change how you visualize the fabric of reality? I don't know about you, but it definitely changes it for me. Keep looking up and keep questioning the nature of the cosmos.